All right, ladies and gentlemen, we are back at atomic structure today. We talked the other day about the idea of atomic number, and that the atomic number is found on the periodic table. It's pretty prominently displayed in the square of an element on the periodic table. It's a whole number, always a whole number, and it also tells us the number of protons that every atom of that element has. These atomic numbers can be read from left to right, starting at the top of the periodic table and going towards the bottom of the periodic table. Today we're going to switch gears, but not too much, because we need to remember what we learned about the atomic number as we move forward. And we're going to move into talking about atomic mass, mass number, and isotopes as well. So, in order to get going on that, let's take a look. No, the atomic mass, like the atomic number, is found on the periodic table. So it's in those little squares. However, it's a little different because it is a decimal number in almost every case. There are some of the larger numbered elements on the periodic table that do have some whole number atomic masses, but generally speaking, it's a decimal. And the reason for that is that it is the weighted average of all the elements isotopes. So if we take all the different versions of oxygen, and keeping in mind isotopes has to do with how many neutrons there are, and we're going to talk a little bit more about that in just a few minutes. But I did mention the other day that we have different isotopes of an element when we have different numbers of neutrons in the nucleus of the atom. Always the same number of protons. That's what it makes it that particular element. But when the numbers of neutrons change, then we have different isotopes of that particular element. So let's take oxygen, because we often use that as an example. Oxygen comes in several different isotopes. Okay, we might have some oxygen atoms that have 7 neutrons. We might have some that have 8. We might have some that have 9, maybe some that have 11. If we take all the different variations that we know exist in this world of oxygen, as far as the different number of neutrons, and we add that up and find the average, then that will give us our atomic mass. So let's take a look at a square on the periodic table for just a moment. Remember, the whole number is the atomic number, and the decimal number is the atomic mass. So for oxygen, the atomic mass is 15.999. There are some periodic tables that have it as 15.9994 because they take it out to another decimal place. But that is the weighted average of all the different kinds of oxygen isotopes. So that brings us to the idea of something we call mass number. Now, mass number is not actually found on the periodic table. It is something that we can calculate in an atom, or it is a piece of information that we can be told about an atom, but you're not going to find it on the periodic table. So it is the number of protons and neutrons combined in an atom. So we're talking about one specific atom here. So if we have an atom of oxygen that has 8 protons, because it always has 8 protons because it's oxygen, and it has 7 neutrons, then that means we have 8 protons, 7 neutrons, so a mass number of 15. 8 plus 7 is 15. It's always going to be a whole number because we can't have part of a neutron in an atom. So to find the number of neutrons, we take the mass number, if we are given the mass number, and we subtract the atomic number, which is the same thing as the number of protons. So that will tell us how many neutrons we have. So we can figure out the number of neutrons if we know the mass number, if we've been told what the mass number is, and if, assuming we know the atomic number, which if we know the element, we should be able to know the atomic number. So for example, let's say for a minute that an oxygen's mass number is 16. We know that its atomic number is 8, and that means that the number of neutrons has to be 8 also, because the mass number 16, take away the atomic number or the number of protons, 8, will give us the number of neutrons, because the number of neutrons and protons together make the mass number. So let's practice just a little bit. All right, so we've got a little chart here. Let's start in the first row. We have an element symbol of S. All right, if you have a periodic table nearby, take a look at the periodic table and find the letter S. If you do, you'll see that the atomic number for S, which is sulfur, is 16. So the atomic number we know is the number of protons. They've already told us the number of neutrons, so we can figure out the mass number of 32 because we're going to add the protons and neutrons. As I mentioned a moment ago, we know how many protons there are because we know the atomic number. The atomic number is the number of protons. They're the same thing. And then we're going to assume that all of these are neutral atoms. All of these are neutral atoms, which means the number of electrons has to be exactly the same as the number of protons so that the positives and the negatives balance out, which means there are 16 electrons. Let's take a look at the next row. We don't have the symbol, but we do have the atomic number, which means we can look on the periodic table and go across till we find the number 7. Well, the number 7 is capital letter N for nitrogen. All right, the atomic number 7 is nitrogen. We know it has a mass number of 14. We'll use that a little bit later, but first, as far as the number of protons goes, of course, the atomic number is the same as the number of protons, so 7. The number of neutrons is going to be the mass number minus the atomic number, or minus the number of protons, which means we have 7 neutrons, because 7 plus 7 is 14. 7 neutrons plus 7 protons is our mass number of 14. And then it's a neutral atom, so our protons and electrons have to be the same, so that's also 7. If we go down to the next row, we have an atomic number of 17. Well, if we take a look at our periodic table and we go across till we come to the number 17, we'll see that the symbol is Cl. Cl. We know it's not Ci because atomic symbols always start with a capital, and if there's a second letter, then it's always a lowercase letter. So it's not Ci, it's Cl. Its atomic number we know is 17. That's chlorine, by the way. All right, they've told us the number of protons and the number of neutrons. Well, that's pretty handy because if we know the protons and the neutrons, then we can add those together to get our mass number, which means our mass number is 35. And again, it's a neutral atom, so our protons and our electrons are going to be the same, so there would be 17 electrons out in that electron cloud. All right, last one, here we go. We have a mass number of 40. We have a number of electrons of 20. Well, if we know the number of electrons is 20, and we know that this is a neutral atom, so the electrons and the protons are going to be the same, then we know the protons are going to be 20. And if the protons are 20, then the atomic number is 20. And if the atomic number is 20, we look on the periodic table, we'll see that that is calcium, Ca. So we just said we know the atomic number is 20 because this is a neutral atom. We know that the protons are 20 because we know the number of electrons, and it is a neutral atom. And then if we take our mass number and we subtract either our atomic number or our protons, same thing, we will get our neutrons, which is 20. All right, we'll do some more practice with that another day. Right now we're going to move on to the topic of isotopes. Now, I've mentioned isotopes a couple of times over the last couple of days. So isotopes are atoms with the same number of protons but different number of neutrons. So they're atoms of the same element. We know that because they have the same number of protons. But they have different numbers of neutrons, so they have different masses, because when we add the protons and neutrons together, we get different numbers. Chemically, they are alike. They react with other substances in the exact same way. Having different numbers of neutrons does not affect them chemically. However, like I mentioned a moment ago, it does affect their mass number. They're going to have different mass numbers if they have different numbers of neutrons. And we write it like this. We write the element, or the element name, and then a dash, and then the mass number. So for instance, we'll take a look at some neutral hydrogen isotopes. We could have hydrogen 1, hydrogen 2, or hydrogen 3. They would look a little like this. Here we have a hydrogen atom. Hydrogen always has one proton, and it has one electron out in its little electron cloud. Here in the nucleus, we have one proton, because again, it's hydrogen, has to have one proton. But now we have added a neutron in that nucleus, and then we still have the one electron on the outside in the electron cloud because it is neutral. Hydrogen 3 has 3 particles in the nucleus, the one proton, because it's hydrogen, and then in this case 2 neutrons, along with your electron in the electron cloud. So they all have one proton. They have to. They're hydrogen. All hydrogen has one proton. They all have one electron because they're all neutral, and the protons and electrons have to balance each other out in a neutral atom. However, the numbers of neutrons are different. Hydrogen 1, hydrogen that has a mass of 1, has no neutrons because there's only one particle in that nucleus of that atom, just the proton. Hydrogen 2 has 1 neutron because its mass of 2 is made up of 1 proton and 1 neutron. And then hydrogen 3 has 2 neutrons because 1 proton plus 2 neutrons makes 3. We don't count electrons in the mass of an atom because electrons are so incredibly small. Remember, it would take almost 2,000 of them to be able to have the same mass as 1 proton or 1 neutron. So when we're talking about the mass of an atom, we don't even include the electrons because they are so small that adding a couple doesn't change the mass really, hardly at all. All right, so we're going to summarize all of this up because, to be honest, that's a lot of information in a short period of time. But we can kind of simplify some of this a little bit into some phrases that might be easier to remember. So, the atomic number is equal to the number of protons, which is equal to the number of electrons for a neutral atom. So atomic number equals protons, and in a neutral atom, it also equals electrons. The mass number is equal to the protons plus the neutrons. So the mass number, the mass of the atom, is equal to how many protons it has plus how many neutrons it has. And then we can find the number of neutrons if we happen to know the mass number, and we subtract the atomic number, or same thing as subtracting the number of protons. All of those statements are true. All right. So ladies and gentlemen, if you have questions, please let me know. You do have a quiz coming up soon, so check in on that. And after that quiz, we'll be moving on to a new topic of ions. All right, ladies and gentlemen, have a great day. Bye.